Hi there, grade 12s. In this video I'd like to go through the isomers of the C5 hydrocarbons. Both the pentanes and the pentenes, as well as the pentynes. So the pentenes the alkane's general formula is CnH2n+2. So pentane will have 5 carbons and 12 hydrogen atoms in it. Pentene is an alkene, so it will have, for N carbons, it will have 2 N hydrogens. So this brings us to C5H10. And for pentyne, with a triple bond between 2 carbons, the general formula is CnH2n-2. For pentyne, then, with 5 carbons, there will be 8 hydrogens. The longest chain structure for pentane would be the carbon with 5, with a chain with 5 carbons. It take care to make sure that each carbon has 4 atoms joined to it. So with only single bonds, this is called a saturated hydrocarbon. Pentene, there is a double bond between 2 carbons. I'm going to start off with a double bond between the first 2 carbons, and then to complete the molecule, only single bonds. Now, to ensure that each carbon has 4 bonds, this first carbon takes 2 hydrogens. You see the first carbon loses a hydrogen when the double bond is formed, when you move from the alkane to the alkene, and the second carbon also loses a hydrogen atom from it because of the double bond, the extra bond between the carbons. So to move from an alkane to an alkene, the atom loses 2 hydrogens. So the alkane will have 2n+2 hydrogens, the alkene will have 2 less hydrogens. That's why the general formula is CnH2n. Just to ensure that each carbon atom has 4 bonds to it, we complete the molecule like that. To move from the alkene to the alkyne, there is a triple bond formed between 2 carbon atoms, and here, to complete the 4th bond, this first carbon takes 1 hydrogen, so it's lost another hydrogen here, and the second carbon has lost its hydrogen when we move from a double bond to a triple bond. The rest of the molecule, each carbon atom needs 4 bonds, so we add the hydrogens to complete the molecule. So this is pentane. This is, with a double bond, we need to indicate exactly where the double bond is. So we will number the carbon atoms in the longest chain so that the double bond will be bonded to the lowest numbered carbon. So this is 1 pentene, or we could say pent 1e. This one is 1 pentyne, or we could call it Pent 1 ine. Righto. Now I want to go into a positional isomer for Pentene that will move the double bond. Let's try it. It's a trial and error story, this. Moving the double bond to between the second and the third carbon. Will give us this molecule. Now this would be called 2-pentene, because the double bond is between the second and the third carbon atom. Now you can't start numbering these atoms from the right hand side and say 1, 2, 3, 4, 5 and say this is 3-pentene, because the double bond must be on the lowest possible numbered carbon. So 3-pentene is not an isomer of pentene. Need to remove those numbers from there. So these two isotopes, these two molecules, are called positional isomers. A positional isomer for Pentyne would move the triple bond to the second carbon, and the same rule applies to this molecule. This can't be a 3-pentyne for the same reason you can't get a 3-pentene. So this would be 1,2-pentyne or Pent 2 ine. That concludes the positional isomers of pentene and pentyne. I want to move on now to the chain isomers. So for pentane, I'm going to reduce the chain to have 4 carbons in the chain, with the 5th carbon forming a side chain. This is called a methyl side chain, because this group here, this group of atoms here, would have been methane. It's got 1 carbon. If it was 1 carbon with 4 hydrogens, so the methane becomes methyl, and this methyl group is joined onto the second carbon in a chain that's got a length of 4 carbons. So 1, 2, 3, 4 carbons in the longest chain gives that molecule the basic name of butane. And with the methyl on the second carbon, it would be 2-methyl butane. You can't move this methyl to the third carbon in the chain, because then you just count the carbon chain, the longest carbon chain's atoms from the right hand side to the left, and you'll see that it will still be 2-methyl butane. I can though make that chain shorter, change it into a 3-carbon chain. the 3-carbon chain will have a methyl group here on the 2nd carbon, and I can place it on the same carbon above. So here I've got 2 methyl groups on the middle carbon in the 3-chain long hydrocarbon. So this, I can't place that methyl group on the 3rd or the 1st carbon, because that will then just still be a butane. So here we have, if we've got 2 methyl groups on the carbon, it becomes a dimethyl. So on this 2nd carbon here, we have 2, 2 dimethyl, and the basic name for this chain would be propane, because it has 3 carbons in the longest chain. So there we have 3 chain isomers. These are chain isomers of pentane. To form a chain isomer of pentene, we need to move one of the carbons from the longest chain to form a side chain. So this one would be, if I add the methyl group there, this would be 2 methyl 1 butene. 2 methyl 1 butene. If we move the methyl group to the 3rd carbon, this would be 3 methyl 1 butene. You count the longest chain so that the carbon, the double bond, would be on the lowest numbered carbon. So this is 3 methyl 1 butene. So this molecule is a positional isomer of that molecule. The 3 methyl 1 butene is a positional isomer of the 2 methyl 1 butene, and it's a chain isomer of 1 pentene. Last set of molecules, a chain isomer for the pentyne. There is only one possible chain isomer here, and it's the one where we take the 1 pentyne and we move one of the carbons to the 3rd atom carbon in the carbon chain. So here we have 1 pentyne, 1 butene, and there's a methyl on the 3rd carbon, 1, 2, 3, 4 carbons. So this is 1 butene, and there is a methyl group on the 3rd carbon in the chain, so it's 3 methyl 1 butene. These are the structural isomers of the hydrocarbons with 5 carbon atoms in them. Hope you find this video useful, and to see you in the next video. Thank you very much for watching.